In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So in this picture, I have that N is perpendicular to L. That's why I have that box there. And I have that these two lines are parallel. What can we now conclude? N is perpendicular to M. Good. Okay. So now let's take a look at some real life examples of some of these theorems we did today. Broadway intersects 12th and 14th Street. 12th Street is parallel to 14th Street. Well, let's just draw that real quick. 12th Street, 14th Street, we just said that they're parallel. It's parallel in Quincy, isn't it? 12th Street's the one that is on the side of junior high and then goes past McDonald's, kind of, right? Hospital, made right. You guys with me? 14th Street's on the other side of Quincy Junior High and then kind of hits Spoonwave, kind of in that area, I think. Okay, so 12th and 14th, though, is parallel. 12th Street is perpendicular with Broadway. You agree?
Yeah.
So 12th Street is perpendicular with Broadway. How is 14th Street and Broadway related then? No. First, just tell me real quick, what are they? What would 14th and Broadway be? Perpendicular. 14th would be perpendicular to Broadway. Now, tell me the if-then statement for the why. It's literally that, isn't it? So if you want to save yourself time, do that, but you can't do that on a homework assignment. Okay? So, it's because of that theorem. If a line is perpendicular to one of two parallel lines, then it has to be perpendicular to the other. Okay? All right, next. In the diagram below, lines A, B, and C are coplanar, meaning they're on the same plane. What conclusions can you make about lines A and B? They're parallel. Why? Okay, so I can't write that. So look back on page 3 for the theorem. Good. If two lines are perpendicular to the same line, then they are parallel. So that was on page 3 of your notes. All right, last example. Shelley sketched coplanar lines M, N, and R on her homework. She claims that it shows that lines M and N are parallel. You agree we can't say that?
No.
What other information does Shelley need to know? Chayton? And what do we want M and R to be? We want them to be perpendicular. So if we knew this, then yes, Shelley would be right. But since we don't, Shelley's wrong. So why? It's this theorem right here again. Okay, we can't say that they're parallel if first they're both not perpendicular.